Okay, for Math Box 1.3, we're looking at some very similar problems to the ones that we've done in the past. Number 1A says solve 700 times 50 equals blank. Again, we're going to go ahead and make sure we cross off those zeros, one on each side here, and here 2, and here's 3. So we know in our answer we're going to have 3 zeros. Makes that math a little bit easier. Now we're just doing 7 times 5 is 35. So my answer for 1A is 35,000. B, again, paying attention to what it is asking us. We want something times 40 equals 3,200. And I have 1 0 here and 1 0 here, so I still need one more 0. So I know this answer is going to have a 0 in it. And so now I'm looking at 4 times what equals 32. And we know that 8 times 4 is 32. And so 80 times 40 equals 3,200. For C, again, I have this same type of problem as B, except it's written in a different order. The equals, the answer is first. So we're going to go ahead and cross off our zeros. I have 1, 2 here, so I'm going to cross off 2. I still have 2 left, so there'll be 2 in my answer. And now I'm looking at 9 times what equals 36. And we know that 9 times 4 equals 36. So 900 times 400 is 360,000. Okay, for here, if we just do some mental math, we know that's 1, 2 zeros, so I can go ahead and put those in my answer. And then simple math of 8 times 3, and 8 times 3 is 24. So my answer is 2,400. There is another way where I could do D if you wanted to do it the long way. 80 times 30. You'd take that 0 and multiply it by all of the numbers on the top starting at the right. So 0 times 0 is 0. 0 times 8 is 0. Going to the next number, that 3. So I'm going to drop down a line and add a 0 there because again really it's 30 times each number. So 30 times 0 is 0. 3 times 8 is 24. And then when I add those two up, 0 plus 0 is 0, 0 plus 0 is 0, 4 plus nothing, and 2 plus nothing, 2,400. Again, giving us the same answer, just doing it in a little bit of a shortcut. Question number 2 is a story problem. Roger played his new video game 4 times. His scores were 1,230, 2,400, 1,570, and 2,630. How many total points did he score? So our question, remember we need to figure out what it's asking us, and they want to know how many total points he scored. So this is an addition problem. So then I'm going to highlight the words or the numbers that I need to use. So again, I'm going to add only 2 digits at a time. So I'm going to take that first one, 1,230 plus 2,400. Add those two first. 0 plus 0 is 0. 3 plus 0 is 3, 2 plus 4 is 6, 1 plus 2 is 3. Okay, so then I'm going to take the next number, 1,570, and add it to my total from the first two, so I'm keeping this running total going. 0 plus 0 is 0, 3 plus 7 is 10, 6 plus 1 is 7, plus 5 is 12, 1 plus 3 is 4, plus 1 is 5, so 5,200. And then I'm going to take my final number, 2,630, and I'm going to add it to my running total again. 0 plus 0 is 0, 0 plus 3 is 3, 2 plus 6 is 8, and 5 plus 2 is 7. So his total score was 7,830. And again, we want to make sure we add a unit on there because we want to know 7,830 what. And so we're looking at points that he scored. So we're going to add that is our unit. Points or points scored. Either way, okay? So 7,830 points scored. Question number 3 says to fill in the circle to tell whether each number sentence is true or false. So we have a little bit of solving here to go. So for number 3A, we have 196 minus 39. 6 minus 9, you can't do it, so 16, borrow from here, minus 9 is 7. 8 minus 3 is 5, and 1 minus nothing is 1. So 153, our answer here is false. So you go ahead and fill in that bubble for false. B says 2,500 equals 1,800 plus 700, so I'm going to take that 1,800, add 700, 0 plus 0 is 0, 0 plus 0 is 0, 8 plus 7 is 15, and 1 plus 1 is 2. So 2,500, that one is true. The next one, we have 8,035 minus 3,049. 5 minus 9, you can't do it, so you have to borrow. Now we have 15 minus 9, which is 6. 2 minus 4, you can't do that, so we're going to borrow from here. There's nothing to borrow from here, so we're going to make that a 7, and this a 9, and this a 12. So 12 minus 4 is 8. 9 minus 0 is 9, and 7 minus 3 is 4. 4,986, which makes that true. And D is 65,050 minus 58,060. 0 minus 0 is 0. 5 minus 6, we can't do it, so we're going to make that a 15, borrow from here. There's nothing to borrow, so you need to borrow from the next number. So 15 minus 6 is 9. 9 minus 0 is 9. 4 minus 8, you can't do it, so you have to borrow and make that a 14. So 14 minus 8 is 6. And 5 minus 5 is 0. So 6,990, again, would make that answer true. So A is false, B is true, C is true, and D is true. We're looking at a bar graph here for number 4, and it's preferred lunches for the number of students. They have different lunch items: pizzas, tacos, nachos, hot dogs, and other. Question A says, which lunch item is most preferred? That'd be the one with the highest bar, pizza. Is the most preferred. Lunch. B says, how might you use this information from this graph? And you could have many different answers here in this one. Something similar to knowing what to order for lunch. If it's a pizza day, you're going to order more lunches than, say, if it was a hot dog day or an other day. So it could be knowing what to order for lunch. Knowing what to order for lunch. So each student has what they'd like to eat. Obviously, on a pizza day, you don't want them running out of pizza. Okay, so number 4. Question number 5 is writing mixed numbers as fractions. We've had fractions before that we've had to change into mixed numbers. Now we're changing those mixed numbers back into a fraction. Whoops, sorry about that. And so first things first, we're going to multiply and then add. So those are the 2 steps that you need to remember for changing mixed numbers into fractions. So again, those 2 steps: multiply, then add. Your denominator will stay the same. So for this, you're multiplying your denominator times your whole number and then adding your numerator. So for this one, and you might want to write this, we're doing 3 times 2 is 6 plus 1 is 7. 7's my numerator. Again, that denominator stays the same, so 7/3. You're not going to reduce that. They wanted it as an improper fraction, okay? For B, we're going down here. 11 times 3 is 33, plus 5 is 38. Again, my denominator is going to stay the same, so 38 over 11. C, again going back up to the top, we're multiplying and then adding, so we're doing the denominator times the whole number, which is 49, and then we're adding the numerator, so 49 plus 2 is 51. 51 over, denominator stays the same, so 51/7. And finally D, we're doing the denominator times that whole number. 5 times 4 is 20. And then we're doing 20 plus the numerator, which was 2, is 22. So 22 over, my denominator stays the same, which is 5, 22/5. Normally, for this type of problem, when they want us ordering fractions from least to greatest, I would say turn it into a decimal. But looking at this problem, we don't need to do that. And the reason we don't need to change it into a decimal to put them in order is because if I look at the denominator here, they all have the same denominator. So it's going to be just as simple as looking at that numerator. The smallest number goes first, the biggest number goes last. Okay, so again, paying attention to what order it is that they want you to put it in, least to greatest. So we're going to start with the smallest fraction, 1/7. I'm going to cross that off so I know that I've used it. Then I have 3/7 next. Cross that off, you know you've used it. 5/7. There's no 6s, there's no 7s. There's an 8/7. And then an 11/7. Okay, so again, this one was easier because it has the denominator the same for all of the problems. So 1/7, 3/7, 5/7, 8/7, 11/7. Again, least to greatest.